Hi, my name is Andy. Today we're going to talk about the derivative. The definition of the derivative, which you might remember from class, is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. You might recognize this from your textbook, and sometimes they use a delta x instead of h, but it should be a formula that looks pretty familiar. Now I'm going to show you a simple substitution that I think rearranges this formula so that it makes a lot more sense, and it really shows the purpose and the spirit of the derivative. So let's take h equals a minus x. So now we have f prime of x equals the limit. So we're taking h approaches 0, so the difference between a and x is approaching 0, so we're taking the limit as a approaches x of f of a minus f of x, because x plus a minus x is just a, so f of a minus f of x over h, which is a minus x. Now I think that this second definition is much more useful because it really shows the purpose of taking the derivative. This part might look familiar because it's a slope, and at the end of the day that's what a derivative is, a slope. For example, if you have a curve and you want to take the derivative at a certain point, what you're really doing is finding the slope of the tangent line at that point. So what this formula shows is that if you were to take secant lines along the curve as a approaches x, eventually as a and x get extremely close, instead of taking the slope between 2 points on the line, you're finding the tangent line that intersects at exactly 1 point, which is x. So I hope that this slope formula is a bit more familiar looking and shows really the spirit of the derivative. And it's also useful, the definition of the derivative, to actually find a derivative for use in calculation. You probably have certain formulas memorized for how to take a derivative. Take down the exponent as your coefficient and decrease it by 1, or the derivative of ln is 1 over x, things you've just memorized. But if you encounter a problem on a test that you don't recognize or you don't remember how to take the derivative, you can always come back to these formulas to actually just calculate the derivative. And sometimes one formula is an easier path to finding that derivative than the other, so it's helpful to know both. For example, let's say that we wanted to take the derivative of root x. So f prime is the limit as a approaches x of square root of a minus square root of x over a minus x. Now let's take that and multiply it by root a plus root x over itself, which this whole term is just equal to 1, so you're not changing anything. So root a times root a is a. You have a negative root x times root a and a positive root x times root a, so those cancel out. And then you have minus root x times root x, so you have a minus x over a minus x times root a plus root x. And you're still taking the limit as a approaches x of this entire thing. So you have an a minus x over an a minus x, so that just becomes 1. So this whole thing goes away. And now you just have 1 over root a plus root x. But you're taking the limit as a goes to x, so this just becomes 1 over root x plus root x, 1 over 2 root x, which is the derivative that you would have expected had you used the rule of taking down the power, the way you normally do it. But it's confirmed by the definition of the derivative as it should be. So I hope that this little substitution has shown you a little bit more insight into what the derivative actually is.